All right, we're going to work on the Unit 2 review, and this unit was a pretty large unit, so I would almost expect that it could potentially be 3 videos to cover all 3 pages of the chart, but we'll see what happens. When you look at your chart, you're going to notice that yours is blank and mine isn't, and I did that on purpose. So I'm going to kind of talk through it, but you might need to pause the video so that you can record everything that is in each box, and then we'll do the examples together. So just remember, the whole point of the video is that you can pause it, you can rewind it, you can replay it. So do what you need to do to make sure that your chart is completed. Okay, so first up, Unit 2 was all about exponents and equations. It was more on exponents. It was very little on equations. So we're going to spend most of the time on this chart working with exponents. So first, exponent is just a way to write multiplication. So when we multiply by something over and over and over again, we use an exponent. And the large number that you write is the base, the small number is the exponent. And this exponent tells you how many times to multiply the base number by itself. So this right here is going to tell you to multiply the base. So it's going to be base times base times base, dot, dot, dot. So this exponent is going to tell you how many times you're going to multiply the base by itself. We never multiply the base and the exponent together, ever. And then anything that has a 0 as the exponent equals 1. So just a couple of examples. If we had 3 to the 4th, that, would mean 3 times 3 times 3 times 3. If we had, let's see, we'll do some color changing here. If we had 1/2 times 1/2 times 1/2, we would have 1/2 to the 3rd, which you can also say is cubed, which I don't think is necessarily important for the milestone, but just when you're speaking. Also, whenever we have a fraction, we are going to put it in parentheses. All right. You could also have -7 times -7 times -7 times -7. We'll just say that. When you write an exponent that uses a negative as the base number, again, you're going to use parentheses. Now, you might think it's not a big deal, but it is a big deal if you're using a calculator. Because if you put 1/2 to the 3rd power, it's only going to cube the last number you put in. And if you put -7 to the 4th power, it's only going to multiply the 7 by itself, not the negative. And so that can cause you to have a different answer. And then the last thing is if we had 123 to the 0th power, that is always equal to 1. I guess I should also mention that it works with exponents too. So if you had m squared, that means m times m. All right, so now we're going to talk about roots, and this is not just a square root, because we also did some cubing in this unit, but if you remember, we made those flashcards with the numbers that you should know, and I think it's very helpful to know those numbers, especially when you're going to estimating square roots, which is our next topic. So if you want to take a minute, if you need to pause this to write all this down. Roots are the opposites. So a root undoes an exponent. It's almost like multiplication and division are opposites. What you're doing is you're working backwards to find the base number. This is the symbol. It's called a radical. And for every square root that we have, or anytime we do an even root, there's 2 possible values. And that's very, very important for next year in Algebra 1. But anytime you have a square root, you are going to have a positive and a negative possible answer. So, to do some examples here, let's say we had the square root of 25. All right, so what you're trying to do is figure out what number did you multiply by itself twice to get 25? And the deal is that it could be a positive 5 or it could be a negative 5. So this symbol right here represents positive and negative. So I'm just going to cross that off because that's actually not part of the answer. That was just me demonstrating. But if we did 5 times 5, we would get 25. And if we did negative 5 times negative 5, we would also get 25. So that's why there's two possible answers for each square root, or anytime you do an even root. And the reason why I'm saying that is because we could also do a cube root. So let's say we had the cube root of 27. So now what we're thinking is, what number did we multiply by itself 3 times? So what number cubed gives us 27? And hopefully you know that that's 3. The problem is that it's not negative 3. Because if we have an odd number of negatives, it's going to give us a negative answer, and we don't have a negative answer, we have a positive 27. So what that means would be that if we had the cube root of negative 27, that would be a negative 3. Because negative 3 times negative 3 is 9, times negative 3 would be negative 27. So whenever you take the square root of a number, whenever it's an even root that you're taking, it is going to be two possible answers. So let's say we had the square root of 121. That's going to be 11 or negative 11. And you can see I wrote this one differently than I did up there. That's just another way you could write it. All right, if we had the square root of, we'll say 625, you might need to think about this a little bit, but the square root of 625 is going to be positive or negative 25. So those were the ones that we did. We didn't do any that were fourth root or fifth root. We only did square roots, which is the basic one, and then a few cube roots. All right, next up is estimating, and I love estimating. And what we did on estimating, we're just estimating. We're not trying to find the exact value. You can divide it to find the exact value, but we're just estimating. So you might just be asked to estimate between two whole numbers. You might be asked to estimate to the nearest 10th. So that's what we're going to practice right here, because we'll end up practicing the other also. All right, what we're doing is first we need to find the closest perfect squares on either side, so the one above and the one below. And then we're going to find the middle, which hopefully you remember I showed you an easy way to find the middle of two square roots, and then you're going to estimate from there. So let's say that we had, oops, sorry, I keep turning the page. Let's say that we had, let's do the square root of 109. All right, so first thing that we did is we looked at this on a number line, and you don't have to, but since I'm trying to refresh your memory, I'm going to go through all the steps. So the first thing that we need to figure out is what numbers does the square root of 109 fall between? Well, hopefully you're thinking of the square root of 100 and the square root of 121. This square root of 100 would be 10. Square root of 121 would be 11. So what that tells us is that the square root of 109 is going to be 10 point something, okay? Because it's bigger than 10 but smaller than 11. All right, then I told you how you could find roughly, it's not exactly the middle, how you could find approximately the square root that would go with 10.5. What I told you was that this is 10 times 10, this is 11 times 11, so this must be 10 times 11. So the middle square root would be 110. All right, so then where would we put the square root of 109? Well, if I was putting the square root of 109 somewhere on this lineup, I would put it right over here. So I'm going to say that the square root of 109 is estimated to be 10.4. All right. Hopefully that is a good enough example. And again, if you need to replay that one again, and I'm happy to do more examples if you need one, but I think just for the length of the video, I'm going to keep going. All right, next up is rational numbers. So this unit talked about rational numbers and irrational numbers because that involves square roots. So this is the list of everything that is a rational number. So again, if you need to pause the video to get these written down, I'm just going to mention each one and put an example over here. Okay, these are rational, okay? So it can be an integer, 7. It can be 0. It can be -5. All right, it can be anything that is a fraction already is rational. So 1/2, 2/3, 3 1/8. Okay, so we did integers, we did terminating or repeating decimals. All right, so let's think about this. We have 1/2 right here. That 1/2 is a terminating decimal because that's the same thing as 0.5. So if 1/2 is allowed, then 0.5 is allowed. All right, this one, I wouldn't expect you to know this, but this is 3.125. So again, that one's allowed. Those are terminating decimals because they end. But let's look at 2/3. I think you should know that 2/3 is a repeating decimal. So repeating decimals are rational. Last one is square root of a perfect square. So we have 7 right here. So if we have 7, it would make sense that the square root of 49 would be allowed. If we have a -5, it makes sense that the square root of 25 would be allowed. So if it's a square root of a perfect square, and those were the ones that you made your flashcards for. Now, I just want to mention about repeating decimals and terminating decimals. When we do terminating decimals always go over a power of 10. So it would go over 10 or 100 or 1,000, whatever your decimal is. When we have repeating decimals, those are going to go over 9 or 99 or 999, and that's what causes them to repeat. So if we had, let's say we had 0.4 repeating, that is a repeating decimal. As a fraction, that would be 4/9. But if we had, let's see if I can fit it in somewhere. If we had 0.4, that is a terminating decimal, so that's allowed. But as a fraction, that would be 4/10, which then we could reduce by 2 to be 2/5. So I think the hardest part of this is remembering that repeated decimals are okay because they do end up to be fractions. All right, so let's look at irrational numbers. Irrational numbers are non-repeating, non-terminating decimals. So the most famous one is pi. All right, it's also the square root of something that we don't know. We don't know what the square root of 17 is. That's because it's irrational. It goes on forever. We don't know the square root of 3. We don't know the square root of 6. We could have pi divided by 2. That would be fine. We could have 5 pi. That would be fine. But anything that has pi, along with anything that is a non-perfect square, if you're taking the square root of a non-perfect square, that's going to be irrational. So again, if you need to pause or replay the video, please do, and I will start the second one in just a minute.